Hi folks, we're going to take a look at number 9 from page 414. So here we've got a parallelogram determined by these two vectors. They give us a name for the fourth point, okay? And then, well, we're doing a lot of stuff to this parallelogram. So I think at this point here we should draw a diagram just so that we can put everything in its proper place, okay? So here, again, remember parallelogram or any shape always goes in the order that the letters are given. So here, O just represents the origin. So here I've got 0, 0, 0. There's my origin. And I'll go from O to B. Okay, and then B goes to C. And then C will come to A. And then finish off the parallelogram. Okay, and we have that OB. So this vector here is just 3, 1, 4. And then we have OA, so from 0, 0, 0 to A is 4, 2, 4. So that vector there. Okay, and now we've got that point C. Okay, and now now that I've got my diagram, let me try to figure out what they're talking about. So a line is drawn from B perpendicular to the side AC. So there's the side AC. So I need to draw a line that comes perpendicular to AC, okay, and they call this N, intersects AC at N, so this is point N, and what they want is they want the length of B to N, okay, so this is what we're looking for here, and this is a nice problem because I'm actually going to solve this in two different ways. I'm going to take a geometric perspective, and then I'm going to take an algebraic perspective. And I'm not quite sure at this point which one is actually going to be faster, but let's solve both of them. Okay, so I'll put the times in so you know when to start the other one. Okay, so if I take a geometric perspective, well here, first of all, I see a right angle triangle. Okay, now, I'm looking for one of these sides. I go, well, I don't know what C is, but I know that BC or CB, whichever direction I go, is going to have the same magnitude as OA. Okay, so the magnitude of BC is equal to the magnitude of OA, which I can calculate. Okay, and that's just going to be the hypotenuse of that triangle. So here, let's call this the geometric perspective here. Okay, so if I can get an angle in this parallelogram, I can just, use regular trigonometry. Well, here, this angle here, which let's say I call theta, I notice is the exact same angle as the opposite one since it's a parallelogram, and this here is just the angle between A and B, which I can find very easily using the dot product. Okay, so once I have the magnitude, have this angle, I can then solve it with just simple trigonometry. Okay, so let's do that here. So here we have the dot product of these two vectors. So I've got 3 times 4 plus 1 times 2 plus 4 times 4. Okay, so algebraic definition of the dot product is equal to the magnitude, the product of the magnitudes times the cosine of the angle. So here, the magnitude of the first, so this will be square root of 9, plus 1 is 10, plus 16 is 26, so this will be root 26. And this one here is 16 plus 16, 32, plus 4 is 36. So that's just going to be 6, okay, times the cosine of the angle between them. And so here we can find theta. And let's do that here. So what do we got? We've got cos inverse of, let's do this in my head here. So here we got 12 plus 2 is 14 plus 16 is 30. Okay, so we've got 30 divided by 6 times root 26. So here, put brackets, 6 times square root of 26. And what do we got? We've got 11.3 degrees. Okay. So 11.3 degrees. Okay. I already found the magnitude of OA, that was just a 6. So here the magnitude of BC, which is equal to the magnitude of OA, is equal to 6. And so now I can just work with this right angle triangle. So this is equal to 6. This angle here is equal to 11.3. And so now I can just, I guess, use sine since I'm looking for BN. So here I've got sine of 11.3 is equal to the magnitude of BN, and B doesn't matter which direction since I'm just interested in the magnitude, okay, divided by the hypotenuse, which is 6. So magnitude of BN, which is what I'm looking for, is just 6 times sine of 11.3. Okay, we get 1.18. Okay, so not too bad. You know, a bit of work to do. You had to find the angle. Okay, set everything up. But now let's take the algebraic approach. Okay, and what I mean by the algebraic approach is I'm not going to work explicitly with any direction or any angle here. Okay, and this is where now I'm going to remember that, hey, this line BN actually represents the height of this parallelogram, because if I just kind of flip this over and draw my parallelogram in this incarnation here, well, that just represents the height of the parallelogram, and the base of the parallelogram will just be this length AC. Oh, wait a minute, I don't know what C is. Doesn't matter, because AC has the same length as OB. Okay, so what I'm going to use is I'm just going to use the formula for the area of a parallelogram, so base times height. And you might sort of say, well, that sounds pretty geometric, but the fact that I'm not going to be working with the angles themselves, because the area of this parallelogram is just given by the magnitude of the cross product of those two vectors. So this is the magnitude of OA crossed with OB. Okay, the base again was just AC, which is equal to OB. Okay, so here let's write it out. This is technically the magnitude of the vector AC times the height, which is exactly what I'm looking for, which is the magnitude of the vector BN. Okay, so here, number one, we've got AC is exactly the same as OB. And the magnitude of OB, well, we already calculated, is root 26. Okay, and now we just have to calculate this cross product so that we can find the magnitude of it. Okay, so here we've got 3, 1, 4, and I'll carry an extra 3, and here we've got 4, 2, 4, carry an extra 4, and so now let's set up our cross product. So remember, to find the x component, we use the y and z. So here we have 4 minus 8 is negative 4. Okay, for the y component, I use x and z. So here I have 16 minus 12. That's 4. And now for my z component, I use x and y. So here we've got 6 minus 4 is 2. Okay, so the magnitude of this vector will give me the area. Magnitude of AC is the same as OB, which is root 26. And the magnitude of BN is what I'm looking for. So here I've got that the magnitude of BN is equal to, well, the magnitude of this vector here is just 16 plus 16 plus 4. Hey, not surprisingly, exact same magnitude as that one there, over root 26. So that's 6 over root 26. And when we check that out, remember 1.18 was our original answer, so 6 divided by square root of 26 is equal to 1.18 or 1.17, blah, blah, blah. Okay, the exact same answer as we got before. Okay, so this is just to show you that sometimes there's more than one way to approach these problems based on the fact that we've got a more geometric outlook, which involves working with the angles, and then we have a purely algebraic outlook because it's just working with the components